The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
So rate of formation graph. Okay, yeah. In the following reaction, which line corresponds with which gas? So let's just say our example here is at 330 kelvins and we have 2 moles of dinitrogen pentoxide decomposing to form 4 moles of nitrogen dioxide and oxygen gas. Great. Since we know that dinitrogen pentoxide here is decomposing, we see that trend of molar concentration decreasing in only one of these lines, right? So it's safe to assume then that this here would be our dinitrogen pentoxide. Moving on, we see in formulation that, we see in formulation that we get 4 moles of nitrogen dioxide for every mole for oxygen gas here. Therefore, we know that we're going to have a lot more nitrogen dioxide forming at a higher rate. And if we look at the concentrations, it's safe to assume then that here nitrogen dioxide is that line on the graph, leaving behind oxygen down here. Okay, great. One other point that I would like to bring to your attention here is, if we were to look at the average rate of formation for dinitrogen, right, we would see that compared to the average rate of formation for oxygen gas, at any time interval will be 4 times greater. So what I mean by that is, let's just say we were to take this time interval right here, right? And we were to calculate the average rate of formation right here for the dinitrogen gas, right? Or sorry, for the nitrogen dioxide, and for the oxygen gas here, we'll notice that the average rate of formation of the nitrogen dioxide gas is 4 times the average rate of formation of the oxygen gas. And that's also apparent here with our reaction. Also, if we look back a few slides, this makes even more sense because we said that the rate of formation for oxygen gas is actually only 1/4 the rate of formation for nitrogen dioxide. And that's what rates of reactions tell us. Okay, great. I hope that was helpful. Moving on now, let's talk about instantaneous rate of reaction.